In match problem 2, we're given a price-demand equation. In this case, it's already solved for x. So keep in mind, we're always looking for an equation of the form x equals f of p, or x equals some expression in terms of p. So if we're given that price-demand equation as p equals something, the first step is to make sure it's solved for x. And what we're going to do is just take that 1,000 or 10,000 and just distribute that through to write this as 40,000 minus 1,000p. So we've got it in a form that will just be easier to differentiate. So the first thing we need to do to be able to evaluate elasticity of these different price points is come up with that elasticity function, which again is the opposite of p times the derivative of our demand function over the original demand function. So negative p times the derivative of 40,000 minus 1,000p over excuse me, over 40,000 minus 1,000p. So this will be negative p times the derivative of all this will just be negative 1,000. And then simplifying, we could factor 1,000 out of the denominator. Simplify that a little bit. This would reduce down to p over 40 minus p. So this is our elasticity function. We can substitute in different values for p, where again p relates to the price we're going to charge for some item, get that value for the elasticity, classify it as inelastic, elastic, or unit elasticity, and provide some interpretation for what that means. So to evaluate E of 8, we would just plug in 8 for our price point here. Which in this case would give us 0.25. So since our value for elasticity is between 0 and 1, demand is inelastic, which means to increase revenue, we should increase price. In part B, we want to evaluate E of 30. So again, we'd take 30, plug it into our elasticity function, and we would get 3. So since that's greater than 1, demand is elastic, which means to increase revenue, we would want to decrease price. So by decreasing price, we're going to draw more people to come in and buy that product. So even though we're making less per item, we have more people purchasing it. So in the long run, we're making more revenue. And then we would want to evaluate our elasticity function at 20. In this case, this gives us a value of 1. So our demand is unit demand or unit elasticity. So what that tells us is that $20 is the ideal price point. If we increase the price, if we decrease the price, demand will change, but relative to that change in price. So even though we're getting more customers or less customers, that's being offset by our increase or decrease in price. So $20 is where we're going to get the optimal revenue. So a price point of $20 is our optimal price point.